Welcome to Usability and Human Factors, Requirements Engineering. This lecture characterizes the nature of requirements needs. First, we will explain what requirements are and explain why they're needed. Then we will shift to the goals of requirements analysis and different forms of requirements. We will explain why understanding the workflow is a core part of the process of requirements engineering. We will introduce the method of contextual inquiry as a means to discover requirements in the context of workflow. We will also examine the use of affinity diagrams as tools for organizing and representing ideas pertaining to requirements. At the end of this lecture, students should be able to explain the role of requirements gathering in usability evaluation, identify the uses, advantages, and disadvantages of data collection methods used for requirements gathering, demonstrate an understanding of how to conduct a workflow analysis, identify contextual design principles as they apply to the healthcare setting, describe the methods to interpret results of data collection. Requirements are a set of activities that are undertaken prior to the design process or early in the design cycle. Requirements can be defined in the following ways: an explanation of what the system should be or should do, which is very basic to the design process. Requirements may be in the form of documentation of needs in order to communicate between everyone involved in system development. They also reflect a set of goals that define objectives for design. We can look at this slightly differently and answer the question of what we are trying to achieve. There are basically two aims. The first is to identify needs so that the system can support the user's goals. The second is to produce a set of stable requirements that can be moved forward into the design activity. This slide shows some of the reasons for design requirements. We want to make communication clear, unambiguous, and specific on system needs. This clarity of communication is important at the level of interaction with the client or intended community of users and among the development team. Other reasons include the need to identify potential mismatches between user needs and designers' understanding. Such mismatches are a source of significant usability problems and great end-user frustrations. Although requirements engineering can be time-intensive, it can save significant amounts of time, effort, and costs downstream. Once you are well into the development cycle or once a product is finished, changes to it are far more costly. The flip side is that you live with compromises that are not very satisfying. Part of the process of requirements engineering is to develop a set of documents that will guide the design, development, implementation, and maintenance phases of the product lifecycle. This slide shows some of the document types that we will need in the course of doing a requirements analysis. Requirements are conventionally categorized into two groups: functional requirements and non-functional requirements. But they can also be categorized into more precise bins that can be more informative. Functional requirements describe the capabilities of the system and specify what the user should be able to do with the system. For example, the order entry screen of a computer-based order entry system will allow the user to enter the first and last name of the patient and then display the name of the patient. That's a very basic functional requirement. Non-functional requirements include everything else, such as the user characteristics, the nature of the organization, and the need for security. They are not focally concerned with system function. This slide lists a range of specific requirement types. Some of these types will be more applicable in particular settings than others. For example, the environmental factors such as noise would be especially important if the users had to listen for certain signals that designate warnings or the completion of a process. On the other hand, they would be less central in many other contexts where there would be greater tolerance of noise. Understanding user characteristics is a subject that has not received sufficient attention. There is a great deal of variation in user types and in their skill level. It is hard to accommodate everybody, but understanding variation in user type, skill, and objectives could go a long way to meeting some of their needs. There are ranges of methods for understanding users' needs, and each has advantages and disadvantages. Questionnaires are relatively common. They're particularly useful to address very specific kinds of questions. An advantage is you can reach many people. Online surveys are a particular variant that are increasingly popular. There are some excellent tools available like SurveyMonkey. Interviews allow you to explore issues in greater detail. It involves a degree of personal contact, which is an advantage. However, it's time-consuming and involves scheduling appointments with people who may have very little free time. Focus groups allow you to solicit multiple views and build consensus. One of the disadvantages is not all voices are heard. There may be stakeholders who are not given the opportunity to express their views. Focus groups are also very well suited to solicit people's attitudes and thoughts about a particular process, but are less useful for engaging groups in serious evaluations about the efficacy or usability of a product. Naturalistic observation is something particularly useful prior to implementation, but maybe even feed into a system design process. It involves observing people at work, understanding workflow, understanding communication processes, and knowing the event structures of the workplace. It's a very powerful tool for learning about the activities of a workplace prior to implementation. Failing to study a workplace will greatly diminish the likelihood of success of an implementation. The disadvantage is that such observations are very time-consuming, and they involve considerable expertise to do effectively. In addition, once you've amassed a large body of observations and audio recordings, what do you do with them? Analysis and interpretation requires substantial skill, and it's even more time-consuming than the observation phase. To a certain extent, requirements engineering is predicated on an understanding of workflow. Medical work is collaborative, and it involves close coordination of a task. The medical record, whether it's in electronic or paper form, is a coordinating tool that updates providers about changes in patient status and provides access to vitally important shared information. As we will discuss later in the course, documentation often falls short for the purposes of communication, and in the worst-case scenario can result in a compromise of patient safety. The National Center for Cognitive Informatics and Decision-Making in Healthcare states, quote, "We need to understand the way healthcare is currently performed in order to determine how to make cost-effective improvements. This holds true whether the intervention is new procedures, equipment, staff, or health IT, but it's especially important for health IT projects. One key goal of health IT is to improve the efficiency and quality of care, which heavily depends on its workflow. Much of healthcare is coordinated human work that is not about to go away. Health IT, like any important resource, will enable some workflows and constrain others. The workflows that a health IT application enhances must have better efficiency and quality, as judged by medical professionals who are responsible for the care it must support. Making workflow an integrated part of the new design instead of an unpredictable response to it simply makes sense. We can build in better workflows that add value and at the same time avoid awkward or unwanted aspects of workflow that health IT might otherwise cause accidentally." End quote. It is important to note that there is no single, unambiguous perspective on tasks and processes performed by users who are the medical staff. Medical settings include a diverse range of personnel with widely varying backgrounds and experiences in the use of computers. This is a picture of a nurse using a telemedicine system. She's in the process of conducting a video visit with a patient who has diabetes. The monthly visit serves multiple purposes, including getting an update on the patient's status, considering changes in their therapeutic regimen, and educating them about managing their disorder. This is a telemedicine platform that is about 10 years old and is very work-intensive. The objective of the design activity is to develop a more integrated system that will significantly reduce workload. The process we were observing was characterized by the use of a wide range of resources that serve different functions. There were two primary clinical software applications: WebSys, a general-purpose electronic medical record system that also has a project-specific diabetes module, and a project-specific patient management database that enabled the nurses to record patient-specific information related to the program goals, e.g. monitoring behavior goals. Paper patient charts were available for review since the electronic record was incomplete for some of the patients. They contained information that was either not available or not easily accessible through the electronic clinical applications. A yellow notepad was used to record information about each of the visits. On the left display, she is viewing the patient as well as the blood pressure and blood glucose values. The case management software is visible on her right monitor. The desired system needs to support the usual range of data entry and data retrieval tasks. There's also a need to support video communication with the patient. As we discussed previously, medicine is a highly collaborative endeavor. This represents a slice of the activities pertaining to the management of these patients. We now turn our attention to analyzing workflow and communication processes. Analyzing workflow is a multifaceted process. Let's keep in mind that our goals are to understand the need requirements, and this would narrow the focus in line with the specific objectives. We want to be able to characterize the tasks that people do and specify the players involved and their exact roles. Workflow is characterized by a process that can be characterized temporally, that is, in terms of time, and the particular event sequences. In medicine, the event sequences are less tightly coupled than in other domains. In other words, there is more variability in terms of event sequences as well as in the tempo, ranging from very fast in situations of great urgency to very slow when there are bottlenecks in the system. Two other important dimensions of workflow analysis include a description of the available technologies as well as the use of various artifacts, such as post-it notes, as they serve to structure work. Work is constituted by patterns of communication, and it's important to capture it. There's a great deal of detail in this schematic illustration. This represents the flow of information from the nurse's vantage points. There are a number of individuals who are instrumental in this patient care process. Besides the nurse and the patient, there is also an expert endocrinologist who is consulted regularly on matters of patient management. The patient's primary care provider also needed to be part of the loop, as he was the one most directly responsible for the patient's course of treatment. The information was transmitted through 8 communication modalities represented by icons. 3 of them are synchronous, and the remaining 5 are asynchronous. For example, telephone and face-to-face conversation are synchronous because you're talking to someone in real time, while email is asynchronous because the message could be answered several hours later. The selection of modalities is contingent on the nature of the information to be conveyed, the relative distance between the participants, and the periodicity in which they communicate. The medium of communication provides different resources for establishing common ground or mutual understanding. Depending on your requirements engineering objectives, some of this information may not be of much relevance to your project. However, tasks, actors, and communication patterns are instrumental in understanding how work is constituted and how technologies serve to mediate work. Contextual inquiry is a powerful methodology that bears a certain resemblance to ethnography and workflow analysis. The critical difference is that it's much more structured and focused on specific goals pertaining to requirements engineering. The interpretation of data is typically a very time-consuming process. However, with contextual inquiry, the scope of such analysis is tightly coupled to your goals and to the focus of the project. Contextual inquiry is partially predicated on a designer as apprentice model. A designer would work with a user in an apprentice-like role and learn the ropes. The contextual interview is another common method of data collection. Finally, the contextual inquiry method is guided by 4 principles: context, emphasis on seeing what happens in the workplace; partnership, developer and user collaborate in understanding work; interpretation, observations are interpreted to be used in design; and focus, data gathering focused on goals and specific questions. The following 4 slides amplify on these principles. The context of healthcare helps in understanding what happens in the workplace. It includes the social and cultural structure of the organization. The employees of a given organization may be more accepting of changes in workflow and technology than in a different organization. The beliefs and attitudes of an organization have an impact on the success of implementing a new system. Engaging stakeholders or end users in constructive dialogue is one way to move people towards a more positive and accepting attitude towards change. However, by itself, it is not a magic bullet. Attitude change is hard to come by and takes time, consistency, and commitment. Defining requirements necessitates a partnership with users to understand their concerns with technology and to embrace some of their ideas for improvement. The central purpose of contextual inquiry is to define requirements. Observations of the workplace are interpreted into system needs. Requirements should be based on the actual tasks people perform and processes within the workplace. Analysis of others' activities can be used to streamline tasks and eliminate repetition. To reiterate, maintaining a clear focus on one's goals is essential in a contextual inquiry method. It keeps one from getting lost in the wilderness amidst enormous volumes of data. Now we're going to ask you to play the role of a requirements engineering analyst. The scenario is as follows. The staff in a private doctor's office needs to keep track of the patients that have been referred to external specialists. You have been contacted to meet with the head nurse to identify requirements for a system to track patients and external specialists. Requirements analysts start their day rather early. You interview the head nurse. You have prepared a list of questions and take notes on his answers. You ask about the current practice of keeping track of referrals. How many staff members are employed by the office? Which staff members are involved in the current practice? What is each of their individual roles? What documentation is used? What problems are found with the current practice? What solutions have the staff come up with for those problems? What ideas do they have for a future system to automate referral tracking? Can you think of any other questions? What do you think you would ask the staff for their solutions? You started with an interview of the head nurse, and now you plan to do some observations. You have decided to observe the office staff in their daily tasks, focusing on the current method of referral tracking. You have obtained copies of the documentation used in referral tracking, and you take notes about what you see in the office. Did we miss anything important in our observations? Does it elaborate on what we learned from the head nurse interview? You meet with two other members of the office staff. One is involved with the referral tracking and the second is not. You ask them how they feel about the current referral tracking process and if they have any ideas on potential solutions. You take notes on their answers. You meet with the head nurse again to discuss your observations. In discussing what you observed, the nurse is surprised to find out that a staff member that is not part of the process is actually printing out each referral letter and placing them individually in patient folders. He indicates to you that there needs to be security restrictions on who has access to external physician records. The results of this discussion become the requirements for security and privacy of patient data. Why does it matter who prints out the letters? Why would this be an issue or a requirement? As you end the day, you begin to organize your notes into different categories of requirements. You now have an understanding of the purpose of referral tracking as well as the roles and tasks required in maintaining external physician referrals. You make a note in your calendar that tomorrow you need to analyze the documentation and begin to create your own document to communicate system requirements. Once you have collected your data, the work is not done. You need to figure out how to derive meaning from your data and how you're going to translate what you found into concrete requirements that will influence and even guide design decisions. There are a number of ways to organize and simplify your data set. We are going to discuss two methods. Affinity diagrams are used to sort and display ideas from multiple sources. Process flow depicts the overall flow of activities and the relation between parts of a system, including individuals. The nursing flow schematic that we discussed earlier in this lecture depicts a kind of process flow. In that case, it illustrates stages in a communication process. Affinity diagrams display a grouping of ideas and data. The steps are rather simple. Write down individual ideas on a note card or a post-it note. look for ideas with similar themes, group the ideas with similar themes together. The categories can be relatively fine-grained or coarse-grained depending on your goals. This is a relatively simple diagram, and the analysis is not presented at a very fine level of detail, but it illustrates how such a diagram can be used to structure goals for design, keeping in mind the different tasks that people do and the different roles they fulfill. This slide summarizes the requirements engineering process. We need requirements to communicate with everyone on the design team as well as other stakeholders, for example, the personnel who may use such a system. There will be different requirements for different aspects of a system. A key point to emphasize is the need to focus on the purpose of the system while interpreting the context in which the system will be used by partnering with the users. Creating requirements consists of a process of steps that includes interviewing medical staff, observing daily routines within the medical workplace, and analyzing current documentation being used by the medical staff. There are quite a few methods for the process of requirements analysis, including diagrams and process flows. This concludes the lecture on requirements engineering. In summary, requirements engineering emphasizes the necessity of understanding the nature of user needs in the context of system development. Failure to properly consider user requirements can diminish usability and user acceptance of the system. There are several kinds of requirement types. In addition, there are a number of common methods for eliciting them. Documenting and analyzing workflow is an integral part of understanding the requirements of a setting. Contextual inquiry is a method for uncovering requirements in the context of workflow and work practices. Different requirement types and methods for eliciting them. Importance of understanding workflow, methods of contextual inquiry, and affinity diagrams as a method to organize ideas and data.